What if I told you that there are more planets in the universe than stars? That some of these planets are so hot that they rain molten iron, while others are so cold that they have frozen oceans of methane. That some of these planets are so close to their stars that they orbit in a matter of hours, while others are so far away that they take thousands of years to complete one revolution. And that some of these planets might even harbor life forms that we can't even imagine. Welcome to the fascinating world of exoplanets, the planets that orbit stars other than our own Sun. In this video, we will explore the latest discoveries and research on exoplanets, their characteristics, and the possibility of finding extraterrestrial life. We will also learn how astronomers detect and study these distant worlds, and what challenges and opportunities they face in the quest to unravel the secrets of alien worlds. Exoplanets are one of the most exciting and active fields of astronomy today. The first confirmed detection of an exoplanet was made in 1992, when two astronomers found a planet orbiting a pulsar, a rapidly spinning remnant of a massive star that exploded as a supernova. Since then, more than 4,000 exoplanets have been discovered, and thousands more are waiting to be confirmed. The diversity and variety of exoplanets is astounding, ranging from gas giants larger than Jupiter to rocky worlds smaller than Earth. From planets that orbit two or more stars to planets that have no star at all. And from planets that are potentially habitable to planets that are utterly hostile to life. How do astronomers find these elusive planets when they are so far away and so dim compared to their host stars? There are several methods that astronomers use to detect and study exoplanets, each with its own advantages and limitations. One of the most common and successful methods is called the transit method, which involves observing the slight dip in the brightness of a star when a planet passes in front of it, blocking some of its light. This method can reveal the size, orbit, and sometimes the atmosphere of the planet. Another method is called the radial velocity method, which involves measuring the tiny wobble of a star caused by the gravitational tug of a planet. This method can reveal the mass, orbit, and sometimes the composition of the planet. Other methods include microlensing, which uses the bending of light by gravity to magnify a distant star and reveal a planet around it. Direct imaging, which involves taking a picture of a planet by blocking out the glare of its star, and astrometry, which involves measuring the precise position and motion of a star to detect a planet around it. One of the main goals of exoplanet research is to find and characterize potentially habitable planets. That is, planets that have the right conditions to support life as we know it. These conditions include having a suitable temperature, a stable orbit, a solid surface, and a protective atmosphere. The most promising candidates for habitable planets are those that lie within the habitable zone of their stars, the region where liquid water can exist on the surface. However, the habitable zone is not a fixed boundary, but rather a range that depends on many factors, such as the type and age of the star, the size and composition of the planet, and the presence and thickness of the atmosphere. For example, a planet that is too close to its star might suffer from a runaway greenhouse effect, like Venus, while a planet that is too far away might freeze over, like Mars. A planet that is too large might retain a thick hydrogen atmosphere, like Neptune, while a planet that is too small might lose its atmosphere to space, like Mercury. A planet that has no atmosphere might be exposed to harmful radiation and meteorite impacts, while a planet that has a thick atmosphere might block out the sunlight and prevent photosynthesis. One of the most exciting discoveries in recent years is that there are many planets that are roughly the same size and mass as Earth, and that some of them lie within the habitable zone of their stars. These planets are called Earth-like or Earth-sized planets, and they are the best candidates for finding signs of life. However, being Earth-like does not necessarily mean being habitable or inhabited. For example, Venus is also an Earth-sized planet, but is a hellish world with a surface temperature of 460 degrees Celsius and a pressure of 90 atmospheres. To determine if an Earth-like planet is truly habitable or inhabited, We need to study its atmosphere, which can reveal clues about its climate, geology, and biology. For example, an atmosphere that contains oxygen, ozone, methane, or other gases that are produced or consumed by living organisms can indicate the presence of life, or at least the potential for life. This is called a biosignature, a measurable feature that is influenced by life. To detect and analyze the atmospheres of exoplanets, astronomers use a technique called spectroscopy, which involves splitting the light from a star or a planet into its component colors or wavelengths and looking for the characteristic patterns or fingerprints of different molecules or elements. By comparing the spectra of a star before and during a transit, astronomers can isolate the spectrum of the planet's atmosphere and identify the gases that are present. This technique is very challenging and requires very sensitive instruments and large telescopes, especially for small and faint planets like Earth. However, in the near future, new missions and facilities, such as the James Webb Space Telescope, the Extremely Large Telescope, and the Ariel mission, will be able to study the atmospheres of dozens or hundreds of exoplanets and potentially detect biosignatures or even technosignatures, signs of advanced civilizations such as artificial lights, radio signals, or megastructures. Exploring exoplanets is not only a scientific endeavor, but also a philosophical and cultural one. By studying these alien worlds, we learn more about our own planet, our place in the universe, and our destiny as a species. We also confront some of the most profound questions that humanity has ever asked. Are we alone? Are we unique? Are we special? Are we destined to find other life forms, or to remain isolated in the cosmic ocean? These questions have no easy answers, but they inspire us to keep searching, keep wondering, and keep dreaming. With that said, thanks for watching, and until next time.